Hello again. Here is your quick quiz to remind us about the cosmic microwave background, or CMB. Today we are actually going to be trying to answer the opposite end of the spectrum question. Big Bang tries to answer, how did the universe start? Today we are going to be looking at what is the fate of the universe, or where's it going? If the universe is expanding, what's going to happen to it? So this is about the end, in some sense, of the universe. It'll take us a while to get all the way to the end, but we're going to start today by talking about what are some possible fates of the universe. Okay, so first of all, what would the fate of the universe depend on? And how does this relate to what we've been studying? Okay, so we'll start with the idea that the universe is expanding. Okay, first we went backwards with this, and we said if it's expanding, it had to have gotten smaller in the past. Now we're trying to look to the future and say, well, what is that expansion doing? If it's expanding, is it always expanding at the same rate? Or is it going faster, slower? What? So it's expanding, but that expansion can speed up, it can accelerate. That expansion can sort of coast, or sort of keep going. Coast, but kind of keep going, but sort of slowing down. It can really slow down a lot. It can decelerate, put on the brakes, or, well, not or, and is what I should say. If it decelerates, then we have an opposite Big Bang. We have a collapse. So basically that's saying that's collapse, S-E, sorry. What is the ultimate fate of the universe? What's it going to look like? So here's a picture of some of those options, right? So all of them start with a Big Bang in the past. We can keep accelerating, expanding forever. We can coast, which means it's still accelerating, but not really getting faster in our acceleration. A critical universe says we've reached sort of this perfect expansion rate. We're going to stay there. Or we can decelerate here, and that would lead us back to a big crunch or a collapse. So let's look at those and think about how we might be able to answer that question, what is the fate of the universe? So if we're thinking in a physical way, the fate of the universe depends on density. Okay, why? Well, it depends on gravity. So the density of matter, how much stuff there is, gives us a sense of how much gravity there is, and we know that gravity is this fundamental force in the universe. That gravity is what caused the stars to form. Gravity is what holds the galaxies and the large-scale structure together. So gravity is important. And so if we can figure out how much gravity there is, it might tell us something about this rate of expansion. Okay? Why does it tell us about the rate of expansion? Because gravity works in the opposite way. Gravity is attractive. So gravity should slow the expansion. Gravity wants to pull all those galaxies together. Expansion is pushing them apart. Okay. Another really important point here is we need to count all of the gravity, so we must include dark matter. So we need to think about ordinary, luminous, regular old matter, and dark matter. Both of them have to count when we're trying to figure out how much stuff there is in the universe. So the question here is there enough gravity to make that big crunch? Or is there not enough and we're just going to keep expanding forever? That's the question that scientists are trying to answer. And we have a few sort of answers, so we're going to walk down that path. Okay? First, let's say what would happen in each case. Say we don't have that much matter, ordinary and dark matter, and we live in a low density universe. If the density is low, gravity is going to lose, the expansion is going to win, and we're going to live in an accelerating universe. Okay, so the universe is going to accelerate. This is also known as an open universe because it's just going to keep going, right? Get bigger and bigger and bigger. On the opposite end of the spectrum, if we live in a high density universe, then what's going to happen? We have a lot of matter, we have a lot of gravity, so we are going to collapse. We're going to head back the other way, quit expanding, turn around, reverse. We are going to live in a closed universe. There will be an end in some sense, a big crunch, it's often called. But there's another interesting possibility that scientists like to talk about a lot, and that is what we call a critical density universe, a very special case. So critical density, which is an interesting case because it's a slowing down of that expansion, right? It's not getting faster and faster. And it slows down at just the right rate so that it won't ever stop expanding until we reach infinity. Okay, that's kind of odd because you never really reach infinity, right? But critical density is this really special place in between open and closed where we just kind of just barely make it. So here's sort of a graph. This is size versus time. Open keeps getting bigger, closed gets smaller again, and critical is this perfect place in between. Here's that picture I showed again here with the closed, the critical, and the accelerating. Coasting was kind of in between. That would be between critical and high density. So what kind of universe do we live in? Well, we try to count up all the matter, including the dark matter, which there's a lot of dark matter, right? Remember the galaxies were 90% dark matter. And we come up with our best density estimates. We look at all the pictures we've taken of the night sky. We try to figure out how much stuff is there. That says estimates, if you can't read it. And our best density estimates, don't forget about the dark matter, including dark matter, which is a lot, right? Including dark matter, say we're sort of a coasting kind of place. Say that we will keep expanding, right? That expansion is going to go, but slowly, but we're not quite critical. We're not quite perfect. We have that expansion slowing, but we don't ever stop at infinity. In fact, we never would stop. So there's enough gravity to slow down the expansion of the universe, not make it faster, but we're not quite critical, just a little bit less than critical. Okay? However, this is not the whole story, so stay tuned. Here is a clicker question for you. This is where the story is so far. Just looking at the density that we have so far, what did I just say we would predict? Which of that best fits? Okay, so do that, watch the next video, and then we will talk about